Okay, I'm going to write a program using matrices. So start Visual Studio, and I'll create a new project, console app on my desktop, and I'll just call this one matrix example. Call it matrix examples. Create. And what I'm going to do is I'll write some code to do two operations that I talked about in the lecture slides. One is the transpose and the other is matrix addition. Okay, so and what I'll do in this example, I'm just going to perform the operations without reading in information from a file, but you could read it in from a file. So let's see, IO stream using name space std. Okay. So the first thing I'm going to do here is I'm going to create a two-dimensional array, and I'll tell you what, I'll go up here and I'll create some constants, integer, I'll say row size, and I'll set that equal to 3, and I'll do column size equal to 3 also. So I'll do a 3 by 3 array like that. Okay. Now what I'll do is I'll create two arrays, and I'll put some numbers in them. Let's see. Why don't we make these? I'll make these 2 by 2 instead, just because we'll make it simpler to start with. Okay, integer array, and we'll do it like this. I'll say column size. And of course, I can always change it later on. So I'm going to do a 2 by 2. So first thing is I'll do 2, 3. So 2 rows, 2 columns. So here's my element 0, 0, 0, 1, and then element 1, 0, and then 1, 1. Okay, so I'll say 4, 1. That's good. Okay. Okay. And I'll do another one. And I'll say integer. This is my second array. Call this one B. And you'll see A, B. These are common symbols used in linear algebra for arrays. Sorry, matrices. And column size. Okay, so it's going to be a 2 by 2. And I could put, row size in there if I wanted to. I don't have to. It'll set the size already. And in fact, okay, so I just created two arrays, two 2 by 2 arrays, and I specified the column size. I could put the row size in there if I wanted to, but I didn't need to. Okay, so here's my 2 arrays. And, let me just make this comma 3. So here's my value. So these are integer arrays and, 2 rows, 2 columns. Okay. All right, the next thing I want to do is I'll go up here and I'm going to create a function. So I'll do a function prototype. And what I'll do is I'll just make it a void because we're doing arrays are passed in by reference. So I'll create one more array that will be contain the results of the operation when I do the addition. So I'll call this one add matrix. Okay. And then I'm going to pass in the arrays. So I'm going to say integer. And I'll do it's the same thing, column size. Okay. Comma. And I'll just do this 3 times. And the third time will actually be the third argument, the third parameter that I'm defining is actually used for the result. Okay, so the result into array. So I'm going to create another one here. Let me do one more. I'll do comma, integer, and I'll call this one C, except now I'm going to say the row size. Row size column, because I'm not going to initialize it. This will be the result of the operation. Okay. All right, so here's my addition matrix. So I'm going to use that matrix. I'm essentially going to do a matrix addition for this one added to this one, right? This array elements, each individual element's added together from this first array to the second array and stored in this third one, okay? So when I make my function call, it'll be add matrix, and this one will be, I'm going to pass in A, B, C, like that, okay? All right. And what I'm going to do, I'll create one more function here, and I'm going to do a void also, and this one will be display matrix. So I only do this once, and I'm just going to pass in a single array, okay? So I'm just going to use this function when I want to display the contents of an array. Right? Okay. So let's go and define the function called add matrix. Okay. And it's the same thing here, right? Let's copy this down. The other thing, of course, I need to define them. I'll say A for my A array. B, I'll just use lowercase here. Of course, I could name it the same thing, right? I could use the same names as when I make the call, but I'm just doing this to show you essentially that they are different variables that are used to access it. Okay. So for the array, we need to perform the operations and we need to store them in the end result. All right. The way we can do that is, like usual, we need, since we have a 2D array, we need to use a nested loop. And we need to start at 0. And then the size, like we'll do row and column, and I'll just copy this over, but it's going to be I less than column size. I'm sorry, let me do row size, and then I plus plus, okay? And then the same thing again, except now, oh, semicolon, of course. And except now I'm going to do it with a J. All right, now it's going to be J, 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 and J, okay? Except this is column. Okay, so this is a typical thing we're going to do, and I'll actually use this when I want to display the elements also. Okay, so here I want to do this operation. So the way I'm going to do it is C, I, J equals A, I, J plus B, I, J. Okay. So what this does essentially is that it's going to just, each individual element, I'm going to do a math operation and I'm going to store it in this last array that I had defined called C. Okay. All right. So the next thing I'll do, this is just to add individual elements in the array, right? So this is my function definition that does that. The next thing I'll do is I want to do the display matrix a function. And the reason is, of course, I want to display it before, which I could do that. I can display A and B, and then I'll display C after, okay? So let me do that. I'll just do this. I'll just copy it down. So matrix, and I'll just call this one, let's say result. I don't know. I don't have a good idea what I want to call it, but that's my matrix I'll use here. All right, and I want to do the same kind of thing here. So I'm just going to copy this down. And then I'm going to display it. So I'm going to do a cout. And then it's called result. So I'm just going to use result I j. Okay. And oh, I want to put a tab in there or something because otherwise they'll run into each other. Semicolon. Then I'm going to do one more thing here. Every time I go through and display all the columns, I want to do an end line. That way, you know, in terms of displaying it, it'll look better. So I'll do end line like this. Cout end line. Okay. All right. So now here's my display matrix. So this just displays the matrix that I want, right? Whatever I pass into it, either A, B, and C. So then I'm just going to go up here and I'll do display matrix. And then first time I'm going to pass in A. And I'll do it again. And I'll do a cout just to show you, give you a new line, right? And then I'll do it again. Same kind of thing. And then I'll do a B, right? So I'm displaying the B matrix. So really I'm just displaying this matrix A, and then this matrix B, which contains this, and then the result of the two, okay? So it's just same thing, except this is C. And we can check the result at the end. Okay, so there it is. Here's my just displaying what the contents are, you know, my matrix or my grid. And here is the adding each individual element. And then we'll take a look at the math here and see, because what do we expect? The first element, when we do the addition, is going to be 2 plus 4, so it'll be 6, right? So the first element in the corner is 6. And then this of the second row should be 6, and then the next one will be 3 added to 2, so it'll be 5. Okay, so 6 and 5 is what we should expect here if it works properly. So I run it, and I get an error, and integer expected. Of course, there's an error here. I don't need to go and specify that the data type's right. I could put on separate rows if I wanted to and put semicolons here and do it, but of course I already have the data type right here, so I don't need to put it here and here. Okay, so there I corrected that and running it. Okay. Okay, let me do system pause and return 0. Okay, and now when I run it, okay, so there's the 2 minus 4 3 1, and here it is. Let me make it a little larger. Over here, click. So I just right click on here, get properties, and then you can make a larger font to see it. Okay. All right, so 2, 3, minus 4, 1, got it. 4, 2, 6, and 3, got it. And then here's the addition. 2 plus 4 is 6, yep. 3 plus 2 is 5. Minus 4 plus 6 is 2. 1 plus 3 is 4, okay? So there you go. So there's the end result. So it appears to work correctly. Okay. So the next thing I'm going to do is I'm going to take a look at transposing matrix. And we'll start with function prototype. And transpose matrix just is going to reverse columns and rows, okay? And column size. So it's just going to take the columns and make them rows and rows columns, okay? So just exchange the rows and columns. Okay, there's transpose matrix. And so let's go down and just oh, I need another array here. And this one will be, I'll do comma. I'll call this one D. So D, and same thing, row size, and then column size, like that. Okay. And then what we'll do, okay, so I actually deleted this other part. I needed to do this, Control V. This was C. That's what I had before. Okay. So down here now, I'm going to go down and I want to do the function definition. And I'll just use this code right here. It already has my loop structure in it. Okay, so void transpose matrix. And what I do, let's see. Oh, I need to actually pass 2 in, right? Actually have another one. This will be the result of the transpose. I need this because otherwise I'm going to overwrite the other one, so I really need the second one. Okay. So whatever array. So let's say I want to transpose C. I'd pass in C and D. Okay. So here we go. So integer. Well, let me say, I'll call this one input because it's my input array. And column size. And then I'll call the second one my result. So I'll do integer result, call it whatever I want. At least these have some significance in their meaning. Like that. Okay. All right, and let's see. So we're good. Okay, so let me go down here. And I'll just, like I said, I'll just copy this one in. Add matrix. Okay. So this is what we need to do. To take the result, instead of doing this as an addition, the transpose, what I'm going to do is I'm just going to have whatever result it is. So I'll say input I, J, and then just reverse it. Result J, I. Like that. Okay. Now after, so this is the actual function definition. This just, what does it do? Just exchange rows and columns. Okay. That's all that it, that's the function definition for that one. And then what I want to do, so I got to make a function call here, and then I'll do a display matrix. So transpose matrix, and I'll pass in 2 arrays. So C, comma, D, and then I'm going to do a display. I'll just do a display D. So let me just copy this one. Control B. Okay, so I'm going to display the matrix D, which contains the transpose matrix. Okay, if it works correctly. All right. So we display the matrix A, display the matrix B right here. Then we do an addition, and then display C because it stores it in C. C is this is the result of added matrices. Okay. And then the last one here, result of transpose. Okay. And in our case, it's transpose of C, right? Because that's where we do. We took C and we transposed it, put it in D. Okay. So let's go and run this and check our results. Okay. And there it is transposed. So now we have essentially what was the first column, or column 0 becomes row 0. And then column 1 becomes row 1. Okay. So that works correctly. So that's the basic example where you can do some matrix operations fairly easily anyways. Uh, and like all I did was add. I could do a multiplication if I wanted to, division, subtraction. It really doesn't matter. All the same kind of operations. We just change this here. And we also have the transpose. Transpose is another operation. There's another thing in there I'll read about called determinant. Determinant's also a useful value. It's a little more involved in terms of the calculation, but it's a similar, similar idea using the 2D approach. But this gives you some basic concepts and how you can use 2D arrays in linear algebra, at least performing matrix operations. Okay, and that's the end of that example. I'll put this code on the website.